Yes, it was great.
Hello. Okay. So, also warm welcome from my side. My name is Maik Baehr. I'm working for a Siemens company now since 2011. Next slide, please. Yeah. Okay, perfect. So I'm a system architect for ATO. I'm located in Braunschweig in Germany. If you never heard of the city, don't bother. Before I started my career at Siemens in the software development department, so I did software for ATO onboard, for example for TempSync, for example for the project Vasilius mentioned when we automated the cargo locomotive and some other Asian metro systems. Today it's my part to talk about ATO and TempSync, so we really go on a specific project. We are not talking about ATO in general and what might be possible. We have a look on the reality. If we talk about TempSync, we're talking about a GOA2 system. So this term has been stressed in advance. I'm not sure whether you are familiar with this kind of terms, but in general we distinguish mainly between 4 different grades of automation. So the first one, which is GOA1, GOA0 I leave out because usually we do not have trains anymore, or often without any ATP system. GOA1 means there's an ATP system on board, but the driver is fully in control of the train. Maybe supported by a driver advisory system, but that's it. In GOA2 we have an ATO onboard system installed, where the driver is able to push a button and then the train is moved automatically towards the next station. In GOA3 we have a train attendant available on board, but there's no one sitting at the driver's desk because sometimes there's no driver desk available anymore, only some levers which are hidden by coverage. And in GOA4 we have fully automated and no attendees on board. And I can tell you that in the mass transit world in particular, we have GOA3 and GOA4 already on the track, so this is in series. GOA2 for mainline now, for example, TempSync, I will give you some details right now, that's also going into operation pretty soon. And often it is mentioned that the automotive sector is on a really good way, and I do not want to say something different, but I have to emphasize again what Vasilius mentioned, that some cars are driving around, they are still testing. Whereas in mass transit we have it already in series, the higher levels of automation. In the automotive sectors they are far away from that. Okay, so now let's dive into the topic, TempSync itself. So the track layout is depicted here. There's one we always call core area. So we have mainly 4 stations within the central London area, where you can see it, I guess. There's a frame around this. So we have I don't want to say it's a problem, we have the challenge that all the trains coming northwards and southwards, they have to go on the same track to pass the inner city area. And that's a problem. Pardon? Yeah, okay, thank you. Now I'm out. Yes, that's the core area, and all the trains are approaching like this towards this area, and the train needs to be in sequence, in time, in order to do not delay other trains, because this is a kind of bottleneck. Well, before the TempSync project started, there was a national deployment study by Network Rail, when several suppliers were asked, for example, Alstom, Invensys, which is former Invensys now, and us, Siemens, where we made studies to see, okay, based on an existing track layout, what might be the capacity you can reach with our system. We proposed to go for ETCS level 2, and then finally we got the contract. So they had different requirements, and I just added here some important requirements. They want to increase the capacity. I think Mr. Lochmann yesterday told us a sentence that ATO is not a toy to play with, right? And it shall increase the capacity on the network. And TempSync is a really good example for this. Like I showed you, we have a bottleneck, only one track for each direction, and they want to have 24 trains per hour in direction in a stable manner. And also they asked that they want to have a recovery mode, when they can shorten the headway to have 30 trains per hour. This means 2 minutes headway. Also there's one big requirement, that the platform reoccupation time, this means this is the time from wheel stop to wheel start, that this shall not be higher than 45 seconds. because they want to keep the time, or the time the train is dwelling at the station limited, and within those 45 seconds, the door should be fully open for 30 seconds. So this is really challenging. And like I told you, ETCS Level 2 and ATO, they are combined together for this, and as far as I know, this will be the first project where ATO and ETCS Level 2 is combined. And also we offer the DAS system for the National Train Control System, so TPWS and AWS, that's the UK National Train Control System, in order to guide the trains towards the tunnel or towards the core area. And they got a driver advisory system to be in time there. So, and of course, what kind of advantages, I will come to that also later on in the summary. Now I want to show you the train. In fact, I think you already know this is was just a simulation, but in fact the train looks really like this, without those kind of advertising at the side. And here you can see a mock-up of the driver's desk. So we have the ETCS DMI, so our approach was to not bring an additional DMI with us, because as you see, they already have an HMI wiring stock, they have CCTV screens, and now they have the ETCS DMI, and we integrated the ATO and DAS icons fully into the existing one. Or at least the display, which has to be developed anyway. In total, we delivered, or Siemens delivered 115 trains, whereas 60 trains are an 8-car train, right? So 160 meters long, and the full-length unit, which is the 12-car coaches, this is 240 meters long, and then 55 trains are to be delivered. Yes, really, it's a high-level architecture. Nevertheless, it really figures out how this works. So we have a traffic management, which is shore-based, or trackside of course, which has an overview about the current operational situation, and therefore the trains are regulated here. Then we have the European Train Control System, which assures that we have safe movement, so that we do not pass certain distances, that the speed is kept, which is allowed. So there's a frame provided by ETCS. The ATO also is connected to the TMS by the existing ETCS infrastructure. So we are using packet 44 in order to get all the information from the TMS later on. Packet 44, as I told you, relies on the ETCS infrastructure, GSMR, and thus I can tell you that we are secure as ETCS is. Yes, the onboard unit is more or less the same like written above, so the Safe Movement Authority, which is provided trackside, is supervised and monitored by the ETCS onboard unit, and the ATO now is the component to control the train in a perfect manner and to realize the operational commands which were given by the TMS. Now I want to invite you to a virtual train, just to give you a feeling how this holy magic works. So imagine we are already at the station stop, and there's an animation. So when the train is arrived at the station, we send an arrival signal towards the TMS, so they are always aware when exactly a train arrived. Then we get a departure time for this station, and the driver is now made aware by a dwell time indicated on the ETCS DMI. So he has always in view when he has to depart. And to support the punctual or the in-time departure, this time is counting down, and then the departure procedure is commenced. Once the doors are closed, the ATO button will flash, and to indicate, okay, dear driver, you could take me into operation now. And then usually the driver is supposed to engage the ATO, and then a departure signal is issued by ATO. As a result, we get the runtime to know, okay, what is the time at the next station we have to arrive. And then the ATO calculates such a trajectory, so I do not have to talk about energy-receiving movements anymore, thanks to Alish. But nevertheless, this trajectory is calculated on board, more or less on the fly. And then there should be an animation now that the train is moving to the next station in a perfect manner, considering the most energy efficient curve, and then again is stopping at the station in a high accuracy, And additionally, it's also important to emphasize that the doors are opened automatically. This was one outcome when we have to support those 45 seconds station dwelling time and 30 seconds opened. Then you need automatic system to control the doors. Well, in general, I can tell you, of course, that the stable head rate can only be achieved by ATO and ETCS, so that's our opinion. That's also what we profounded in our study during the national deployment study. Like I told you, there is a recovery operation possible for 30 trains per hour, just if something gets wrong. The station dwelling, that's for the 45 seconds is supported because you have the dwell time indicator, you have a real, I don't want to say aggressive, but a real straightforward braking towards the station. And yes, also the doors are opened automatically. Also one big advantage if you want to have a stable head and also to have a stable operational situation, you always need a connection to the TMS. So the TMS is always aware of everything, and if they had to send any updates, they need to be realized immediately by the trains, and that's what ATO does. And also, if you go to a recovery operation mode, then you have the problem that you're very close to preceding trains, and for this you need a tight interface between ETCS and ATO on board. So Baehr has mentioned that this is subset 130. This is not right in detail, because when we set up the specification in 2011 and 2012, we were not aware that there would be a subset 130 in future. But I can tell you that we also, that's why we sit together in Shift Array. I also participate in those meetings for GeoA2, that we brought in our knowledge and experience on this interface in order to also design the subset 130. Yes, that's all about ATO, and then I just want to give you an impression, because we are talking about digitalization here in general, and ATO is only, well, from my personal opinion and also maybe due to my personal preferences, ATO is a big topic, but nevertheless, if you have a view on the total system, this is only one topic of a lot. I can tell you that for example, for the driver advisory system, we cannot use the GSM-R because we are outside of ETCS area. That's why we have to use the GSM public. And for this, we rely on the public infrastructure, and therefore we also had to think about security in detail. But we have a strong partner because Rolling Stock, in this project, Siemens is also a Rolling Stock partner. They already have a server. When the trains are always connected via an encrypted VPN towards the trackside system, and there we implemented our ATO backend, which is also responsible for the DAS purposes. So you get track data base, for example, the timetables, they are updated via this. And of course, you have all these fancy stuff now that you can make some analysis, diagnostic, and also the users, the customer can use this web interface to do their own analytics. Well, so far from ATO, so I have to give you, my contact details are given here, so if you want later on to ask me for my contact details, I forgot my card, so make a photo of this or download the presentation afterwards. And also I would like to tell you that in the coffee room there is some advertising materials of ours, so there's also an article about ATO and Temsig in particular inside this magazine, so you can take it with you and then read it and order an ATO. Okay, so thanks so far. Hopefully I was in time.
You were exactly in time, Maik. Jan, now that's up to you for the last presentation before the coffee break. We are all thirsty, but you will manage to